I will quickly pass it to Godfrey for the code quality session. Go ahead, Godfrey.
Okay, thanks a lot, Simeon. Just quick intro for the team that I'll be presenting with. I've got Louis Dali, Victor Dieva, as well as Emi Bukasa. And generally in our work, we've got more additional members. The ones that are pretty much regular contributing are those mentioned in there. So in this, we're just going to try to quickly squeeze a lot of work that we do throughout the PI in about 30 minutes or less. Then if there's any other questions or follow-ups, we're happy to take that during the course of the PI or anyhow offline. Just quickly, for those that might be new to this presentation and Mojaloop in general, we, as the code quality workstream, we were really dedicated on two things, which is, improving the trust and data privacy of Mojaloop, so that, alongside with a big intention of adoption and engaging largely in a very large financial ecosystem, we can, with confidence, give, to a degree of guarantee the things that we're doing to make sure that it's trustworthy as much as we can. So this is actually an extraordinary effort wherein, yes, the functionality team do consider much of aspects of quality and security, but over and above that, we work with the functionality team, and we also own some of the non-functionality elements of this, be it on the application layer, infrastructure layer. So around that is our approach. How do we normally approach this, working with an open source community? We take an approach of really taking what we already know, which are the basics controls and the basic standards that are dictated by industry standard. We look them very carefully for relevance into what we do, and we incorporate them, as part of our work. But we will also be very cognizant of, transforming them a bit, given the changing nature of the technology that we're using. We're a little bit more cloud native, and we're a little bit more early starters in many things that we're doing and how we do it. So we actually introspect those, previous control that are known to be working, and adapt them to Mojaloop. We don't put lots of strict policies, lot of strict standards. We put them out there as guidelines for anybody adding a new functionality to Infer. And we take also a risk, centric model, wherein we sometimes look at the specific risk that is facing us specific to a particular functionality, so that we don't overload security with risks that are not that important. That is in a nutshell. So in terms of where we started, we started pretty much, before PI 8 with much of what was built into the API around, MTLS signatures, which is actually deep down the API protocol. And also we continue with a special focus initiative thereafter, closing, all the critical gaps that existed. But so far, we're really doing very good where we are. So that is in a nutshell about what we do in the stream. In terms of the objectives for this PI, we defined about 7 epics, which we actually see them as long-lived, wherein PI to PI will have specific target and objective to achieve. So we have those PI multi-PI objectives, and alongside with that, we pick a scope for every PI based on the priority and the need. And in this PI, what you see in the last column in blue for PI 12 objectives is really the objectives we set aside for us to achieve per epic. And also a little bit on how we get to decide this is really, much more looking deeply into the product we're building, and working with the product council, working with anybody that brings in new functionality to make sure that, whatever is added is in line with the standards we have. And also we use it as an opportunity to transform how we do security. And also, I've touched the alignment to best practice standard and also continuous improvements of controls. And threat-centric, I've touched it. And also we open up for criticism. We open up to our implementers. We open up to the community to come forward with the things that they think we should be doing differently, or we should be doing better, or we should not be doing them at all. So in a nutshell, that all informs the decisions we make finally to say what are the things that are critical for us to look at. Moving on to what we have done this PI, what I'll do is I'll give a quick high-level summary of everything we've done, and I've lined up my team members to drill a little bit more deeper on specific aspects of this. Because of time, we will not touch everything else. So as divided by epics, the functionality support epics, these epics really focus on all the new functionalities being added to the API set. And in this PI specifically, there were a number of things that we have done for PSP, around threat modeling, and it's also looking on the how we secure, OTP by looking at FIDO implementation. And that is actually, something that we will take as an exit point with the recommendations going forward. And for the RFM, which is a new baby on the block, we actually firstly and foremost, we aligned with their dev teams in terms of, the policies we have around open source usage and the tools we're using. In certain instances, they brought new tools altogether, and we actually have looked at them and we accepted them, and we're fully aligned in terms of, all the DevSecOps practices that we have. And going forward, which is still pretty much in review stages, is around looking at the finally opt for, because they presented a couple of options to the DA. And because of resource constraints, we'll focus only on the design that is selected, to do more, review and assessment around it. The next one was really the IAM epic as well as the data protection. So there was a lot of, things that we're actually doing on the data protection. We have done a lot previously with the focus on GDPR, focus on privacy data. So in this PI, we really were preparing for a next steps to really take some of the standards and recommend configuration and test them in the lab so that we can actually promote them into productive environment. And also on the AM side, we completed the CPM initiative. We started with the low-level designs, and we'll move ahead to select one or two use cases to implement. And Emmy will take us through the FIDO investigation we have done and the recommendation on how we can embrace it going forward. On the DevSecOps side, this is kind of like lots of maintenance work that we're doing here with Lewis and Sam. And, operationally, we looked at, the vulnerabilities, the patches. We're trying to reduce the amount of window period from when the vulnerabilities is detected to remediation. And they were working hard there. We've got plans to automate the release as much as we can, and also to make use of the ML operator to notify the implementers. And also on the enhancement side, we looked at the repos, reorganized it, get the access, and license part, just to make sure that we are in line with what we opted as our license policy. We updated the license across the Mojaloop org. Again, on the critical part of our workstream around engagement with our implementers, regulators, or anybody that is looking our way, we looked at the previous documentation we have when we reorganized a little bit so that everything can be in one and can be easily accessible, easily updated. Luis will actually touch a little bit on that. And also, we trace some of the concerns that we received from the community around K8 security object, and we have plans to address that. Lastly, but not least, we're also looking, to continue with this, with the support to our key implementers, so that, there's no any, something that can create a gap for them to not reach their compliance. So for Mowali specifically, we look deeply into the GDPR compliance, and, we address a couple of gaps that we identified as per sheet here. And also we initiated a new kind of like journey for them to bring forth their AML requirements. As you know, our RFM stream is still kind of like long way from being productionalized, but however, there is immediate requirements around this to meet, but we address those. So without much ado on this, that's in a nutshell what we achieved. And I'll hand over to Luis to really pick the next two epics and delve a little bit deep on them. Luis, over to you. I'll run the presentation from here.
Yeah, no worries. Hey, hi everyone. Thanks Godfrey. Thanks everyone for having me today. I'm Lewis. I'm based in Australia, one of the open source developers on the team. So yeah, I think Godfrey touched on this a little bit really, for us, a lot of what we do in the CQS stream is the maintenance work and upkeep with both our kind of node modules and dependencies, and making sure we're keeping on track of any security vulnerabilities that get announced. And we also went through and did a GitHub clean, spring cleaning, if you will. I think we started it in spring in the Southern Hemisphere, so I think that works. So yeah, we archived a bunch of repos, still probably more to archive. We've improved some of the security steps, and along with some of the other restructuring, made sure that we've got the right level of permissions so people can't make it harder for bad actors to put bad code into Mojaloop, and really just streamline the processes around that. Next one, Godfrey. The other one, yeah, was about documentation. We've got a lot of documents that the CQS stream has produced, and they're floating around in the ether into different places. So we really wanted to bring them all into one place, centralize them, and also be ready, because we get a lot of requests for information, for example, like a security vulnerability reporting procedure, and we want to make sure that that documentation is easy to find and, yeah, easy to send links and available for people to kind of check out. So we went through and pulled together a bunch of our different documentation and linked it all kind of from a common place in the Mojaloop documentation repo. Have you got the demo there, Godfrey, or do you want me to share my screen?
Let me just share it from your end so that you can drive it.
No worries, yeah. Let me just set that up. So here's just a quick example on our GitHub page. This is going up on the Mojaloop documentation page, but you can also find it here. Quality and security workstream, we have kind of 3 main sections. Stuff around the program management, the stuff that we get up to in this workstream. We also have a couple of reports, so things like the GDPR scope analysis and some of the PCI DSS baselining reports that Godfrey and the guys and the team worked on. We've got, I mean, I won't bore you by just stepping through all these documentation things, but also just links to some of the other specification documents that we've already produced, but kind of tried to centralize them in one place for someone coming at Mojaloop from that security lens to be able to take a look at what it is that we're doing and analyze and learn, and hopefully this is a useful thing. I think that's all from me, Godfrey.
Yeah.
Is there anything else you wanted me to say?
I think that's all. One other step that we will take is really to, look at the Mojaloop training that has been released and do a one-to-one alignment with some of the messages they're saying here and that they're saying there. Okay, and with that,
cool.
Thanks, Louis. I'll quickly hand over to Victor for the next section, for the next 5 to 7 minutes for the PSP work as well as data protection. Victor, over to you.
Okay, thank you, Godfrey. Hi, everyone, and really glad to be here. Lots of really good presentations so far. I think from the presentations we've had that one of the aims of Mojaloop is to now have a wider outreach in terms of deployments, have more projects, and have large-scale deployments happening across the globe. Now, with that, of course, will come a lot of regulatory compliance obligations. And as the CQS workstream, we are very keen to ensure that we have both specific and generic compliance obligations implementation within Mojaloop that can allow any implementation to streamline itself alongside their own risk appetite. Now, in terms of what Godfrey has already highlighted, we were supporting the PISP workstream. In the previous PI, we were looking at their linking process and how customer gets onboarded into the PISP process. In this PI, we went further into the mobile application that's going to be developed. And specifically, we were trying to ask ourselves, how are we going to generate and store some of the credential artifacts that will be generated during the process? And some of the key focus areas that we were trying to look at was, how are we going to ensure device security, application security, data security, and network security? focusing on the mobile device that will support the PISP process. We had some really good findings as we looked at both iOS and Android. Number one is that both of them are iOS FIDO level 2 certified. That is from Android version 7. Further research shows that 78% of all Android devices run version 7, which is good. However, there needs to be a bit of further research to understand from an emerging market and the target audience of Mojaloop whether these are covered. And then, of course, we found that the devices can also stand in as the security keys themselves. And we also identified that a FIDO server will be required to do any FIDO-based authentication within the process. Now, this Amy will highlight later when he talks through the proposed FIDO architecture to support this whole process. And then we also noted that FIDO requires more of biometric authentication, but Android and iOS allow the lower devices that might not have biometric authentication to work. So from a programming perspective, it will be possible to support PIN or swiping. And then finally, there is a step that is required to enable FIDO on every user's phone that it will be having some possible overheads in terms of operations. Next. Next, Godfrey. So from our STRIDE threat analysis model, we broke down the PISP transaction process into its key areas. One will be the mobile device, which is used by the user transacting, then the requests going through the PISP, and then to the Mojaloop hub, and then finally at the DFSP level. What I did was I classified 3 broad categories. One was the assets, and this I was focusing on the data assets because I'm looking at data protection. Then we had the threat agents that could affect the data, either on the mobile device, within the PISP, within the Mojaloop ecosystem, or within the DFSP. And then, of course, some proposed controls that can work at each of these levels. So we found that within the mobile device, the PISP application will sit alongside other applications within the phone. And this, of course, will raise the traditional risk that a rogue application might try to intercept and read the data within the PISP app. However, we also realized that ever since they achieved the FIDO certification, Android and iOS have really enhanced the data protection at application level, meaning the applications are restricted from communicating with one another. This gives us an assurance that all the credential artifacts relating to PISP will be restricted to use within the PISP application, and it's not possible for another application to say, for example, read the private keys or read sensitive data within the PISP application. Also, we have some common configuration artifacts that are used by all applications, and there we did not see much risk around it. Some additional threat areas included issues to do with jailbroken or rooted devices. We also had issues to do with malicious websites that can be used for phishing within the linking process. And then we also had issues around physical access to the device. So in this case, we were recommending that users must have devices that have security enabled within their phones. We also wanted to recommend that we have a lot of encryption to be enforced with TLS from start to finish. We're also talking about having user authentication and authorization, which we're happy to say the FIDO technology within Android and iOS supports very well with existing APIs that can be used. And then we also want to have input validation and output encoding. Most of these already have standard recommendations from OWASP, which if our developers can stick to, then we can be sure that the development is going to have a robust protection. At high level, some of the other highlights include the iOS and Android code needs to be reviewed to ensure that there is no residual code. This is more of CI/CD protection to ensure that nothing can be introduced at origin that can flow down into the process, and Lewis already alluded to this. When he talked about securing, locking down the GitHub access, we need to have password stored plus additional salted information to ensure an attacker cannot work backwards from the salted hashes to get the encrypted information. And then we also want to enforce credential validation after the user has signed in to ensure that they are the owner of the device. It is possible in Android and iOS to detect that a user has actually unlocked the device or not. And then finally, we need to have login notifications for successful or failed authentications, which must be sent to the user to ensure they are aware of any activities on their devices. The last one is a standard recommendation. We need to find a way of restricting jailbroken devices, which can allow third-party applications to have root access that can allow them to bypass some of these conventional controls. Next, Godfrey. Next, we also looked at data security in terms of the database protection. And I'll just quickly skip to the recommendations. I'll touch on the focus. Our focus area was looking at how we will protect the PII data that will be stored within Mojaloop. We identified, even as Miguel has highlighted earlier, from the various components that we have within Mojaloop, it will be inevitable that PII data will be stored. And because of that, we will need to make sure the data is protected, whether it's persistent data or within the logs or within the data being transported. So from our database standpoint, what we are planning to do is develop policies around access control, TLS encryption on connections. And here we're talking about a service mesh architecture where we want inter-application authentication and encryption to ensure that within Mojaloop itself, the services talk within an encrypted channel, and they also authenticate each other at all times. We want to also test some policies around database hardening that we have documented as guided by CIS standards. And then we will enable auditing for all CRUD actions within the Mojaloop databases. And this will be linked back to the notifications and reporting dashboards that come embedded within Mojaloop, where we shall test and be able to see whether we can have some incident response processes to be recommended to the implementers. And then finally, we recommend reviewing of database code as submitted by developers for any malicious code. This will now fall back within the CI/CD process. Next, Godfrey. So to test some of these policies that we're trying to document and recommend, we have a CQS test lab where we're going to focus on testing all the recommendations we have made this far up to now to identify whether they will work within a Mojaloop environment and to work with the infra teams and the Mojaloop development environment to ensure that there is no performance implication based on the security policies that we plan to enable. Our focus areas in the coming PIs is going to be around the Docker and Kubernetes environment, EFK and logging, where we want to have some dashboards that can show us the security events within the environment. We want to lock down Kafka and ensure that we have the service mesh architecture where we have authentication and encryption between the producers and consumers. And then at the database level, I've already talked about the hardening, as well as establishing a routine process for patching and updating it. At operating system level, we want to also have enabled logging that will be identified within a documented incident response process. Then we look at WSO2 infrastructure. And then finally, we will run some golden path tests in our hardened environment to make sure that we have not A, broken down the Mojaloop instance, and B, we have streamlined processes that we can monitor through the security reports. Back to you, Godfrey.
Okay, thanks, Victor, for the quick update on that. For the next one, I'll hand over to Emmy. Emmy, this is your section. Go ahead, take it. Hi, Emmy. I think we can't hear you, Emmy. Can you hear me? Check your mic, Emmy. I think we can't hear you.
Can you hear me now?
Yeah, now we can. We lost you again.
I think we lost you, Amy.
Hi, Amy, we lost you again.
Can you hear me?
Yeah, yes. Now you're back.
Can you hear me now?
Yeah, continue. I think now you're back.
Okay, my name is Eme Bukasa from South Africa. On a higher level, we've looked at the identity and access management from the governance, reporting, and analytics perspective. So we've looked at the authentication services and the authorization services, the user management services and the directory services, but mostly on the authentication, we've looked at the ASIs and looked at how we can simplify the whole interface. We've looked at SAML 2.0 or OAuth 2.0, the first identity online that we call the FIDO, or the third party identity provider in terms of the Active Directory Federation, Google or Facebook, or the resource providers. We've also looked at the IAM users in terms of permanent users who are system or administrator user, or pool users who are transient for applications. But on the authorization side, we've looked at the roles and yes, we've looked at the roles because it's not only the human users which are considered here. We also look at applications as users. So yes, we can go to the next one. Godfrey. So as a way of simplifying authentication authorization, we've looked at FIDO because password and two-factor authentications, though it is highly secure, but there's a lot of convenience problem there. On the password, security is a bit of a problem, and also the maintenance of the whole password maintenance is also an issue. So FIDO provides highly secure environment and convenience as well in terms of authentication and authorization. Next one. So this is just an overview of the FIDO specifications. There's 3 components. We have the FIDO U2F that I will talk about in a later slide, the FIDO UAF, and the client authenticator protocol. So FIDO relies quite heavily on the principle of authenticators. The web authn as well, which is FIDO that is introduced through W3C, mainly on the browser. All the major browsers have introduced FIDO as well. We will talk about it in the slides that come. But most importantly, we have the underlying technology, which is public key cryptography, which relies on the mathematical properties of the elliptic curve cryptography. FIDO is supported by big names such as Microsoft, Google, and Ubico, Amazon, Intel, Thales, Facebook. Most of the big players are now supporting FIDO. So here, this is FIDO, which is for me the most interesting part because we are talking about the browser technology and the security on the browser, especially for applications that are relying on JavaScript. So basically, the components are the relying party, which is basically the application accessing the FIDO infrastructure, the browser itself, the platform, which is the operating system, and the internal authenticator, if the machine or the mobile device comes with an internal authenticator. Otherwise, there are external authenticators as well that can be used, such as the phone itself or some wearable or just a USB token. But most importantly, what we are introducing in the ecosystem is the FIDO server itself. We will talk a little bit about it and what will be its role with regard to the applications that that need to access the FIDO infrastructure. Next one. Next one, Godfrey. Yes, this is FIDO. The next one, yes. Here is just the UAF, FIDO Universal Authentication Framework. Basically, on your mobile, you will just be presented with, you know, if you are doing a transfer with the information, and it will just be basically authorizing a transaction based on the biometrics. It can be a fingerprint, it can be a face recognition, or it can be just a PIN or a password, which is really the lowest level of security. Next one. And here, it's another part of FIDO, which is basically what we call a U2F. Basically, from your browser or from your application, you will log in, but on top of that, you will be requested to insert, for instance, a USB key. I've personally done some development using the YubiKey external device, where you just slot into the USB, and the application will prompt you to ask you if you are happy with to carry on with the transaction, and you'll just click on a small button that is on top of the YubiKey itself, and the transaction will go ahead. Next one, please. So here is really just to talk quite quickly on how we are intending to introduce FIDO. FIDO basically will be a server that will sit on top of the CPM, which is basically the interface to the crypto environment. The FIDO server will also have its own database that will basically store what we call the user handle, which is the entity that is shared between the device and the FIDO server. So what will happen is once you start the how do we call it, the registration process, the authenticator will generate a handle. It will also generate a private and public key. The private part will stay into a secure element within the phone or within the computer, and the public key will be sent to the FIDO server. So subsequently, what will happen is every time the device would want, or the application would want to do what we call an authentication, the private key, which is inside the mobile, will sign basically the data and send it to the FIDO server, which will use the public key to basically verify. Once the verification is done, then it becomes, then the other functionality can be unlocked to continue with the transaction. So basically, it's just a question of hashing the data on the phone, on the mobile or on the computer, and signing it with the private key, generating a signature, and the signature will basically be verified by the FIDO server. But there is a subsequent third level, which is the transaction authorization. Basically, what will happen is maybe a form is presented to you with the amount, with other details that are specific to the user. And what will happen, the mobile phone will basically sign the information, the hashed information, and will send it to the FIDO server for verification with public key. So we have other components such as user management that we can also talk about in terms of permissions that are giving you access to your role, basically to other information that the system needs for the application to run properly. The attestation is basically where you keep the information about the authenticators, because the authenticator, especially the external authenticators, need to be checked as well if you wish to do so, using that attestation, which is basically an external service. So in terms of the PISP, which is a use case that we are looking at, the Mojaloop ecosystem will basically provide APIs in front of the FIDO server. The FIDO server will access crypto functions from the CPM. Once the registration and the authorization goes through, and the client has basically through biometrics or via PIN accepted the transaction. So what will happen is we will then allow the PID FSP to basically do a credit transaction. So there's a lot of details that I can talk about, but this is in a nutshell how we intend to implement the FIDO infrastructure, basically through APIs that will provide to the third party, which is a PISP, in this case, the relying party, and for them to access the rest of the FIDO infrastructure.
Yep, thanks, Emmy. I think we're a little bit 5 minutes over time. So the last 2 slides was really our exit point from PI 12 and also setting the scene and the scope for the next coming PI. This is really very specific to the AAM Epic, and we'll still go through into the PI planning to see which ones needs to be prioritized. And overall as well, we have our backlog, which the things that will be continuation from the previous PI, and also, priority things that have been mapped out that we need to look at. And yeah, with those, I will just quickly, end it here and thank Simeon and hand back to him.
Thanks so much, Godfrey and team. I appreciate your presentations. Just as a reminder, we will have all these slides up on the Mojaloop agenda page on GitHub. That's mojaloop.io/decks, DECKS.